So this is the first class of the course of programming for problem solving, and since there are various students present in the class, before I start the detail of this subject, I want to introduce the basic notion of computer at the very beginning. So you see, a computer, if I draw a simple design of a computer, it looks something like this. Most of us actually know this. The computer can be defined with three parts. This is what we call input device. This is what we call output device. And this is what we call actually, let's write over here, central processing unit. And sometimes we say CPU. This CPU actually have two main parts within this. One we call processing unit, and another part we call memory unit. This processor unit have mainly two parts. One we call arithmetic and logic unit. So all the operations that we actually do in a computer is done by this particular unit, and a very important part is present, what we call control unit, which basically serves as the brain of the whole system. It actually controls everything. So, and this, there is obviously communication between memory unit and the processing unit, and the data actually is transferred from the central processing unit to the output device to show the output in some form, that may be printing something or printing something on the screen by monitor, printing something on some page and paper in form of printer. It can be anything. And the input actually through the human being, some person, input goes to the computer through this input device, right? So basically, you can say a human being connects the computer with respect to this input device. Maybe it can be a light pen, or maybe it can be some keyboard, or maybe mouse, or anything. So this is the whole idea of a computer. Now, question is that this computer is an electronic device, right? An electronic device means it's actually switched on or off due to presence of some current, or you can say voltage. So question is that obviously which elements are present in this particular electronic devices. The basic elements present in this electronic device are basic three elements are resistor, capacitor, and you can say transistor. Right. Now, somehow, if I want to control this particular computer, any computer, I need current in form of voltage. So, this memory unit is going to be very vital for me, actually for all of us, because whatever data that we will work with, the data should get stored in the memory unit. Now, obviously, this memory unit has several hierarchy. This, if you just take a hierarchy for a moment, this memory unit, memory mainly categorized in two parts. One we call primary memory, and secondary memory. This primary memory has several parts also. One is ROM and one is RAM. It's read-only memory, random access memory. This ROM also have various parts, say programmable ROM, electronically programmable ROM, electronically erasable programmable ROM, in this way. And other than in the secondary memory also have various parts. For example, magnetic tape, magnetic disk, and many more. Maybe flash drive, such as pen drive. This is also secondary memory. So, yeah, various secondary memories. So, I'm not going in detail of this memory part. Whatever it may be, as a memory unit, you can say that whatever data that we will work with, the data is somehow stored, right? If I ask you that what is your name, you will say that your name is say XYZ or ABC, and it's actually you have memorized it. So within your brain, you have something where you can store some information permanently, and there are some place where you can store information temporarily. In the same way, computer have the same thing. Actually, to realize the purpose of a computer, or maybe to realize the working principle of a computer, always remember one thing, that human being has invented computer for some purpose. What purpose, that I am coming later. Since human being has invented it, so naturally a computer works in the same way a human being does, because human being prepared it because to minimize its workload. And when human being invented that, the researcher thought that somehow if we are able to design a machine that can do the same job what a person can do, the workload can be minimized. So naturally, the thought process of a computer is actually a clone of the thought process of a human being, as simple as that. So that is why you see we have some part in our brain that controls everything in our body, right? Similarly, we have something over here that can control everything in the system, that is control unit. We have something in our brain, some part of in the brain that actually computes everything, maybe calculates or maybe try to, you know, take some logical decisions, various logical decisions we take. That, for example, you are you want to go somewhere and suddenly rain started, so your brain logically say that since rain has started I should not go outside. So this is what actually we call a logical analysis. So this logical analysis is done in some part of our brain. Some part of our brain does this arithmetic calculations, addition, subtraction and many more. Similarly, we have something over here that can calculate the same thing, that can do the same thing. That is ALU, arithmetic logic unit. Similarly, we have some part in our brain that can memorize everything, maybe temporarily, maybe permanently. Some part is temporarily, some part is permanently. In the same way, we have something in the machine also that we call memory unit, and memory unit also have two different parts for storing temporarily and permanently. This particular ROM that we are considering is a memory for storing some permanent information. This particular RAM is for storing some, you can say temporary information. If you switch off your computer, the data present in the RAM vanishes. So basically, like you see, this input device that we have to connect with this processing unit, this is the brain. So if you just try to make an analogy with this particular system with a human being, this central processing unit is the brain. And what is input device? This input device is various sensors. For example, that we have eye, skin, everything, nose. So these particular input sensors you can assume as the input device, and as an output device you can say your hand, your leg. These are some output device, because depends on something you can see, how you will move your leg or how you will move your hand, that may vary in some situation, actually in most of the situations. So that means this particular computer is nothing but a simply a similar, like a human being in form of a machine. That's it, that's all. So that means, that's why when you will try to write some program. I mean, if you want to be a good programmer, and if someone asks you to solve some problem, and when you will start thinking how to solve it, don't think from a machine point of view. Think from a person point of view. That how, if the same problem is given to you, then how you will solve that without any machine. How you will solve that on your pen and paper, by pen and paper. The approach that you will take to solve it using pen and paper, the same approach actually you have to somehow express in form of programming within the computer. And if you are able to map that, you are going to be a very good programmer within a very few time. So I can help you to realize this mapping as much as possible, and if you require you can contact me over my phone number and the email ID, or maybe anything, any by any communication. So now question is that we are considering that memory unit can store the information that with which we will work with. The information can be anything. The information can be 1, 2, 3, 4, something like this. Information can be say A, B, C, D, a simple character. Information can be even a sentence, and information can be in any form. But question is that how this ABCD will be understood by a computer? Computer can understand only current or voltage. So since this is a machine, consists of these three important things, which are basically some electrical components that can understand two things: either high voltage or low voltage, right? Other than this high or low voltage, a computer cannot understand ABCD. So for our purpose, we have considered this high voltage as numerical 1 and low voltage as numerical 0 to express it in a better way. That means whatever data that a computer can store in its memory is in some combination of these ones and zeros. So the number system that a computer follow contains only two character or two numerical value, 1 and 0, and this is what we call binary number system. So other than this binary number system, we have three number systems also existing. We will discuss about those number systems very soon, maybe in the next class, but today, at least for today, let's restrict ourselves within this binary number system only as an introduction. This binary number system consists only two. It's actually what? It's a set of two things, only ones or zero, that's all. Whatever data is stored in this one. First point. Now naturally question will come that then how I can store a sentence, hello, how are you? How this long sentence will get stored by only 1 or 0? Not it's only 1 or only 0. It's some combination of ones and zeros. So naturally question will come that what is the length? The combination of a 1 0 can be something like 1 0 1 1. It can be 1 0 1 1 0 1, or it can be only 1 1, maybe only 0, maybe 0 0 0, lot or number of zeros, then 1, something like that. Any combination is possible. But here the length is maybe 4 to 6. Its length is 2, its length is 1, its length is say n, some value. I don't know, maybe say for example 25. But the length cannot be so flexible in the computer system because it is an electronic device. It can store a particular up to particular length, maybe 6 or 7 or 8, but up to particular length. So naturally question will come that how we can realize it with respect to the length. So that means within a I mean, if I concentrate on the memory part, this memory looks something like this. For example, you can assume in this way that memory looks something like this. And this is the whole memory system we have in the computer, and each and every the whole memory can be categorized, can be actually divided logically into several parts. Like this. Something like this. So now naturally question will come, what is this length? You see, if I assume the length of this one is equal to n, what does it mean? It means that you can store n number of one, I mean some combination of 1 and 0 whose length is n. So for time being, let's take n equal to 4. Okay. So that means we have something like 1, 2, maybe 3 or 4. Right this? So we have only 4 boxes where I can store either 1 or 0. So these 4 boxes may contain all 1 or may contain all 0 or may contain some combination of 1 and 0. Naturally question will come. Okay, before proceed about this one, let's understand one more thing, that this each and every bit of each and every information. See this one, a single cell that we have over here is called bit. So this is bit number 1, this is bit number 2, this is bit number 3, this is bit number 4. So what is bit? Bit is actually, you can define it as a lowest unit of storage. Mean this is only 1 bit. This is only 1 bit. Now combination of some amount of bits, it produces larger length. Say this is combination of 4 bits, right? So that means, now question is that what is the next unit that we can have? The next unit that we can have is called byte, which is equal to 8 bit. So combination of 8 bits as a whole is called 1 byte. Similarly, combination of some amount of byte is called 1 kilobyte, or sometimes we say KB, is equal to 1024 bit. Similarly, 1 megabyte we have, this is MB, 1024 bit, sorry, KB. Similarly, we have 1 GB equal to, means gigabyte is 1024 megabyte, 1 terabyte equal to 1024 gigabyte. So just imagine that if you have a machine in your home with 1 TB memory, that how exactly, how length, how much bit you can actually store as a whole. I'm saying as a whole. It's not a single length. So now you see a very interesting thing over here. If you closely watch these particular values, this 8, 1024, there is a similarity between these numbers. Similarity in the sense, similarity in the form to express these numbers. I mean, let me write it. This 8 can be written as 2 to the power 3, right? 2 into 2 into 2. If you do this one, you will see this 1024 is actually 2 to the power 10, and this is also 2 to the power 10. Naturally, question should come that why every time it is coming as 2 to the power? Why not 3 to the power? Why not 4 to the power? Why every time 2 to the power? To realize this question, I mean to realize the answer of this question, we have to understand this one. You see what I have done? See, this is a total memory location. Memory, you can all, sometimes we say memory space, whole thing, right? And the whole memory space can be actually logically divided into a number of parts. So this is part number 1, this is part number 2, and so on. So, and you see each and every part contain a number of bits, right? Here the number of bit is 4, and it can be 5, can be 6, can be anything. So what is the value of n? What will be the value of n? Naturally question will come. The value of n totally depends upon the machine architecture. Machine architecture what does it mean? Machine architecture mean, sometimes you will see, or maybe you say that you have 32-bit machine, 32-bit processor, or maybe 64-bit processor. Sometimes you say, or maybe if you want to go for buying some computer, you can find this type of information. And this particular mean, this is actually depends upon the length of the data bus of the computer. So the length of the data bus of the computer. And what is this data bus? this is actually, you can say, the communication line or you can say channel through which the data is transferred from one part of the computer to another part. Okay. So, so this is entirely depend upon this machine architecture. So assume that you have a machine of 4-bit processor. Okay. Assume that you have a 4-bit processor. If you have a 4-bit processor, that means the data bus having can carry any data having length 4. If it carry a data having length 4, that means in the memory space each and every data somehow should able to store this 4 length data, as if what we have in this particular part, a data having 4 length 4, right? Now question is that if the length is 4, then how many various location that I can have? What I mean, let's try to realize it, that just take the first one only. Okay, just take this first part. First, I mean memory location. This is memory location number 1. This is memory location number 2. This is memory location number 3. This is memory location number 4. In this way, this is memory location number, say, M. My question is that what is this value of M? How we can find this? Let's see. So to find this M, let's take the first part only, the first memory address. The first memory address contain only, not parts actually, each and every memory address have 4 part, right? 4 part, and this 4 part can independently store 1 or 0, right? So that means there is a possibility to store 1 over here, there is a possibility to store 0 over here. Similar possibility is there, 1 or 0. Similar possibility is 1 or 0. Similar possibility here, 1 or 0. And storing in this cell, in this every bit, is independent with the other bits, that I know. That means the combination can start from 0, 0, 0, 0. The next combination can be this part remains 0, this part, the last bit, can become 1. The combination can also be 0, 0 remains same, this 0 can become 1, but this part is remain 0. Another combination can be 0, 0, this part remain 1, and this 0 can become 1. You see, each and every combination are different, and each and every different combination actually signify different data. My question is that how many different combination is possible? A simple problem of combination, permutation combination, you know, a simple question of combination. What is the various number of combination that we can have with these four different data. So assume that we are representing this bit as A, this bit as B, this bit as C, and this bit as D. You see, since I have total, the number of bit here is 4. Possibility of possibility in each and every bit equal to 2. Possibility means either 1 or 0, either 1 or 0. Since the possibility is 2 and number of bit is 4, naturally the combination will become 2 to the power 4. You see, I can also write this one over here. For example, the next combination can be 0 1 0 0. Next can be 0 1 0 1. Then 0 1 1 0. Then 0 1 1 1. Right? If you forget about this part, if you forget about the first bit, just for time being, if you forget about the first bit for a moment, assume that you have a memory location having 3 bit B, C and D. Its possibility is 1 or 0. Its possibility 1 or 0. Its possibility 1 or 0. How many combination possible? 2 to the power 3 is equal to 8. Naturally, you see this is 1, 2, 3, 4, 5, 6, 7, 8. 8 combinations with this B, C, D. So that means if you increase the length of the bit, if you increase the length of the bit from 4 to 5, if the number of bit is 5, number of bit is equal to 5, then number of combination will become 2 to the power 5. If number of bit is 6, it will become 2 to the power 6. This 2 remains same. This 2 because I have 2 possibility. And that is the reason we can see every time 2 to the power 3. This 2 exists everywhere. And if I say that this total number of bit is 4, then naturally I can easily find this m will be equal to what? Will be equal to 2 to the power 4. That means equal to 16. The total number of memory location possible by this 4 length memory location is 16. Right? Total number of location possible 16. Each and every location contain 4 bit. Right? So that means here let's just take a simple mathematical calculation that total number of location equal to 16. Each location have length equal to 4. So total number of bit is what? Equal to 16 into 4. That means 64 bit. That means this particular memory space have 64 bit of storage. As simple as that. So in this way you can easily understand if you have the total length of a particular memory location, then you can easily understand what is the total memory that you can have in a system. Now why I am talking about all these things? Maybe this is the reason why I am talking about all these things is not much clear for today, is not clear for today, but it will be clear maybe in the next classes and so on, because in future we have to calculate many things, depends on the knowledge that we have gathered over here. So anyway, so this is all about the basic realization of a computer. Now naturally question will come that ultimately what we will do, we will learn C language, right? So to learn this language, these are the very prerequisite that you need. What we will see, we can see in the next class, but